May-June 2018, time zone 1, paper 1. This problem is basically combination of sequence as well as trigonometry. The first two terms of an infinite geometric sequence are u1 is 18 and u2 is 12 sine square theta, where theta is lying between 0 and 2 pi. It's a radian. Theta is not equal to pi, that means it cannot be 180 degree. Find an expression for r in terms of theta. R is basically ratio. Ratio is next term over previous term, so u2 over u1. u2 is 12 sine square theta divided by 18. Obviously sine square theta will remain as it is. 12 over 18, common factor will cancel it out. It is basically 6 times 2, 6 times 3, so 2 sine square theta over 3. Please do simplify this as 2 sine square theta over 3. Do not keep unsimplified form. Second, find the possible values of r. We know in trigonometry, sine theta always lying between positive value of 1 and negative value of 1. It's a unit circle condition. So if sine theta is always lying between positive 1 and negative 1, sine square theta, that means negative 1 square should be positive 1 and positive 1 square is again positive 1. So in both sides I am getting a positive 1, so that means upper limit is definitely positive 1 and lower limit has to be 0 because sine is 0 on the x-axis where the value is 0. Sine 0 is 0, sine 180 is 0, sine 360 is 0. So lower limit is always 0 when I am talking about sine square theta. But if I talk about sine theta, maximum value is 1, minimum value is minus 1. But when I am talking about sine square theta, maximum value is 1, minimum value is 0. But sine square theta is not my ratio. Ratio is 2 times sine square theta over 3. So I first did sine theta to sine square theta. Now I will multiply by 2 by 3. But I cannot multiply only one side of the inequality by 2 by 3. I have to multiply both sides. So 0 times 2 by 3 is less than or equal to 2 by 3 times sine square theta is less than or equal to 1 times 2 by 3. 0 times anything is 0. 2 times sine square theta, 2 by 3 times sine square theta is basically your r, and 1 times 2 by 3 is basically 2 by 3. Ratio cannot be 0. If ratio becomes 0, then it is not considered as any series over there. So I am removing this equal to sign and it becomes 0 is less than r is less than or equal to 2 by 3. So these are the possible values of r. Next one, show that the sum of an infinite sequence is 54 over 2 plus cos 2 theta. So when you have cos 2 theta, focus directly on your formula booklet, only cos 2 theta formula. Now here my u1 is 18, r is 2 sine square theta over 3. It's an infinite geometric sequence. So sum to infinity formula is u1 over 1 minus r. u1 is given as 18, 1 minus r, so 1 minus 2 sine square theta over 3. First I will make the base same of the denominator. The base of 1 is 1. 1 and 3 bases are not same, so I will first multiply. 1 times 3 is 3. 3 I will multiply 1 becomes 3. 1 I will multiply 2 sine square theta is 2 sine square theta. So 3 minus 2 sine square theta over 3. You know, division of division is basically multiplication. So 3 goes up. 3 times 18 basically 54 over 3 minus 2 sine square theta. This is not my required answer. My answer is 54, which we already got, but denominator is slightly different. They want 2 plus cos 2 theta. This is the hint which we have to look at for. They have already given what they want, cos 2 theta. So in your formula booklet, there is a formula called as a cos 2 theta is 1 minus 2 sine square theta. We already have 3 minus 2 sine square theta. So I need to rearrange this part. What I am writing 54 as it is, and I am writing 3 as 2 plus 1. 2 I am writing outside, 1 minus 2 sine square theta I am writing in a bracket, which is basically my cos 2 theta. So 54 as it is, 2 as it is, 1 minus 2 sine square theta is cos 2 theta, which is my required answer. this one. Thank you.